In the first two videos of this series, we built an interactive animated list view for our Contacts app. But what if you need to display your data in rows and columns instead of a flat list? That's where the TableModel and TableView come in. In this video, we'll rebuild our Contacts app as a table, complete with resizable columns, cell selection, and both horizontal and vertical headers. Let's get into it. Similar to our previous demonstrations, we will be creating a Contacts application, and we'll be using the same data which was used to create the list view. We will start with an empty QML application created using the new project creator in Qt Creator. The first thing we will do is add imports for Qt Quick Controls, set the component behavior to bound, and import the Qt Labs models modules. Next, we will start creating our model. To do this, we will add a TableModel component, giving it the ID Contacts model. Next, we need to add a set of TableModelColumn components. Each of these will represent a single column in our table, so we will create one for the first name, last name, age, and phone number, and a string which specifies. So, to each of our TableModel columns, we will add a display role and a string which specifies what that column is for. We now have our columns defined, so next we need to define our rows. This is done using the rows property. This property accepts an array of objects, so we will add an array to the rows property. Then each element of the array will define the data to be used for each of the columns. So we will add the first entry as John Doe, giving it a first name, last name, age, and phone number. We will then copy in some more data just to flesh out our model a bit, but it will follow the same pattern as with this entry. We now have a table model with 5 contacts, which is enough to demonstrate our Contacts application. Next, we will add our delegate, which is defined using a component. We will add a rectangle and a text component to our delegate. The rectangle will be the background of each cell in our table, and the text will display the value from our model. We will add 2 required properties, a bool called current and a string called display. These are reserved properties which will be managed by the view once we assign our delegate to it. The current property will be true if the delegate is the current index of the view, and the display property will hold the value of the display role from the model. Using these properties, we can set the value of the text to be the text from the model, as well as adjust the color and border of our background rectangle when it is currently selected. With our delegate finished, all that is left is to implement the view. Unlike the list view, the table view does not handle scrolling by default, so we are going to implement our table view inside a scroll view to allow for scrolling. Next, we will add some table view specific properties. First, we will set the column and row spacing to 1, which will give each of our cells a 1-pixel thick border. Then we will set the rows and columns to be resizable, allowing us to customize the size of our table at runtime. Finally, we can set the model and delegate properties to the IDs of our model and view. The view as it is now would run successfully, however we would not be able to select any cells. This is because we have not yet set the SelectionModel property. The SelectionModel property is used to specify which model should be used when an element of the view is selected. In this case, we will be using our Contacts model, so we will set the model property of the item selection model to be the contactsView.model. Running our application, we can see we have a table with all the data from the model. Each row in the table represents a single contact. We are also able to select individual cells from our model, and we can see they change to pink and gain a thick border as specified in our delegate. However, it is difficult to understand exactly what each column is meant to represent since we lack any headers. Let's fix that right now by adding horizontal and vertical headers to our table. Unlike the list view, the table view does not have properties for its headers. Instead, it uses two separate components called HorizontalHeaderView and VerticalHeaderView. Both of these components need to be manually positioned around our table view. Typically, the horizontal header view appears on the top of the table, and the vertical header view appears to the left of the table. So we will create a horizontal and vertical header view anchoring them accordingly. We will also set the sync view property of both components to the ID of the table view. This will synchronize the cell number and size of the headers with the table view. We then need to adjust the position of the scroll view, which holds our table view, based on the position of the horizontal and vertical header view. So, we will adjust the anchors of the scroll view accordingly. Running our application, we can see we now have a vertical and horizontal header for our table, which counts the number of rows and columns. Resizing the row and columns of our table, we can see that the headers are resized as well. However, our headers still don't label the data as effectively as we might like. Ideally, the vertical header would explain what the data in each column means. So, let's adjust our vertical header so that instead of counting the number of columns, it explains what the data in each column means. Both the vertical and horizontal header views inherit from the table view. Therefore, they both have a model and delegate property. So we can create a model and delegate for the horizontal header view to use to customize how it will appear. We will use a standard list model as the model and a text and rectangle component as the delegate. The list model will contain 4 list elements, each with a display role containing a description of the type of data in each column, which in this case will be first name, last name, age, and phone number. The delegate will use a text component to display the text from the model and a rectangle as a background. We will add the required property display, which will contain the text from the display role in our model. With that done, all we need to do is set the model and delegate property of the horizontal header view to the model and delegate we just created. Running our application, we can see our horizontal header view now has the labels first name, last name, age, and phone number. This makes it much easier to understand what the data in our table is supposed to represent. We now have a complete table view with labeled headers, resizable columns, and cell selection. In the next video, we'll make this table editable, adding an edit delegate so users can modify cell contents at runtime and using model functions to insert entire rows. See you there.